everybody. We're now quite close to ending this series on how to do the trivia refactoring, or my take on the trivia refactoring in Clojure. Last thing that needs to be done is to get this state stack working. Remember the question which we started off with is how to add a back button. If you remember, we had 4 functions in total which are used in the game runner file. We have an add, a roll, and a wrong answer was correctly answered. And we've now reached the level of having all the state in one atom here. Where we are, here it is. And the last trick in order to add a back button is to have a list, a list or a stack of states. And when you call one of those 4 functions, you add something to this to the front of this list of states by taking the current first item and then creating a clone of that with the modifications that you want. Let's see what needs to be changed in order to get this running. Here's the back method. I've already written it. The first thing we need to do is we need to add the state which we need to add something to the state stack. So let's just add it straight to the state stack like this. List add state. We don't actually need the state anymore, the state atom, but let's just do it like that for now, just to save some time. And how do we actually use this with state function? Well, you take a state stack and then you write with state add as player name. That's all you need to do to use this. Let me show you what this does. Trivia.game. Is everything now there? Cider eval buffer is what I want to do. Okay, so now if I do that correctly, we should have something in the state stack, for example. Yes, we do, that's good. And what this with state does is with state takes a list of things. Let's give it something quite similar, something quite simple. And then it takes a function what to run on the first item in this list, and then it takes the result of running that function on the first item in the list and then adds it, then produces a list with the original list as the remainder of it, and the first item is what it's now just calculated. Let's have an example with a little bit more in this list so you can see this more clearly. There we now have 2 things in the list, and I'm just taking the key, the value of A for the first item in the list and adding that to the front of the list. That's what with state does. So if I have a function here which says something like update, let's write it like this just to make it clear. Let's take lm, and what we're doing, we're updating in lm A by incrementing it. Let's do that. And you can see what it's now done is it's taken this first item from the list, that has now become element here, lm in this, and it's updated the first item, the value of the key of it A, value of A, by incrementing the current value, and added that to the front of the state. This can be shortened. And that's a nice thing about Clojure syntax, that this works. It's just a short form of the line above. And it works mainly because of this function definition here, state stack, the function, and then the rest is gathered into a list called args. That's how that works. Okay, so we've now got add done. Let's go to the next function, which I think was roll. This is also quite a simple one. So swap state stack with state roll as roll should do it. The next one to do would be was correctly answered. Swap state stack with state. Correct answer S. Should do that. And now we need to get the value of player 1 from the first element in the stack. Well, that's quite a simple thing to do. We just say get from the first element of the state stack the value of player 1. That's all we need to do. Comment that out. And then the next thing we need to do is wrong answer. The last thing we need to do, stack with state, just wrong answer, S. And if I did this correctly, eShell should do exactly the same thing. Diff should say it's the same, and it does. So I wrote that so I didn't make a mistake this time. That's good. Right, one thing I think would be quite interesting would be to compare this solution, the clojure solution, with the solution I did in Go earlier. So I've copied that here. This is the Go solution in the previous video, and some things are quite similar. For example, the basic structures we're using are similar. You have a player structure, which is exactly, very similar. It's the way to do that in Clojure is this here. Though of course, everything in Clojure doesn't have to be a map, but having maps does have certain advantages in Clojure. And one of the advantages you can see really here is that clone with, you have to write a clone method in Go, because Go doesn't have any built-in syntactic sugar for cloning structures. But lists in Clojure, you can just, maps in Clojure, you can just update a map by saying the key A should be incremented, for example, which you can't do in Go. If you tried to increment, let's say, place or purse here, you'd actually end up changing the current structure. You wouldn't produce a copy of this structure, but with that one value changed. That's not how Go does this, and Go has no syntactic sugar for that. With game, I called it with Go. I called it in Go. It's with state here. It's similar. One of the differences is that you also can pass a variable amount of arguments to the clojure function, which you can't really do with Go. I mean, you could add here that this also takes a list or a large number or a variadic number of further things, but then you lose all type safety. Clojure, of course, doesn't have any type safety, so there's nothing to lose there. But that's basically the same thing. We've got the conj to the state stacks going on in Go as well. In Go, I have this map indexed function in order to update the current player. In Clojure, I could do this update in state and just put the current player I here, current player index, to get the ith element from the vector of players. So you can see how Clojure has a lot of syntactic sugar, or a fair amount of syntactic sugar, or functions, let's say. I'm not sure how much of it is sugar, how much of it is really done by function, how much is built into the language, in order to make programming in this manner quite concise. As a simple example, this Go code, this Clojure code is 162 lines long, the Go code is 274 lines long. Okay, there's the main method as well there, but without the main method it's 244. And I got some comments in the Clojure code which make it even shorter. Okay, many thanks. I hope this has been interesting to you. I will upload these videos soon.